Eldar, Rubinov, Positioning and Geodesy Lead at Frontier SI in Melbourne, Australia. Thanks for coming on the Geospatial Index.
Thanks for having me, Will.
All right, so this episode was largely prompted by quite a popular post you put on LinkedIn recently about it was a summary of cost-effective fit-for-purpose positioning for the 21st century. This was a presentation that you gave at a regional FIG event in Kuching, Malaysia. So I think a lot of us would really love to hear a bit more about how that presentation went, what the points were that you made in there, and how it was received by the audience.
Sure. So, yes, I made a presentation about cost-effective and fit-for-purpose positioning. And positioning has really been changing in the last sort of few years. Until recently, you kind of had this high precision positioning, for which was really made for professional users that have expensive equipment and commercial subscription for corrections that would allow them to get centimeter level positioning. And then on the other side, you had this sort of if you call it mass market users that would have very inexpensive devices or even mobile phones and would not get very good positioning at all. It could be a few meters, it could be that sort of level, and there wasn't really much in between. But in the last few years, that border has started to become more and more gray. So on the one hand, receivers have started becoming inexpensive. The chipsets are becoming inexpensive. They're becoming more powerful, so there's more signals in them. And on the other hand, you get a lot of different services. Some are satellite-based services, some are terrestrial-based, and again, they come at all different price points, and a lot of them are actually free. So for a user, there's a lot of different options now, and this is what I tried to convey in that presentation, that again, there's different types of users in different industry sectors that all require different types of accuracy. Some of them require things like integrity, which means knowing exactly how confident can you be in your position, that sort of thing. So that's really the kind of the big picture of that presentation.
Okay. You said that some solutions are free. I mean, coming from my background's been in engineering consultancies around the world, really. A lot of those companies have sort of come with their own surveying team, and they'll have an incredibly expensive real-time kinematic surveying or positioning sort of a setup. You're talking sort of tens of thousands, $30,000 in some cases. So it seems like there's a huge range in cost. What can you achieve in terms of accuracy with the kind of positioning system you're talking about? If I say only have $500 to spend.
Okay, so yeah, there are quite a few options. So you can now buy even RTK, dual frequency RTK. I don't know if you can call them receivers or boards, but that option is there. So you can buy it as cheap as a few $100s. And then depending on where you are in the world, like in Australia, there's actually a lot of reference stations and the access to them is free. So if you know what you're doing, if you know which base station, your nearest base station you need to connect to, you can actually do it for free. But if you want a kind of a more sophisticated service, like a network RTK service, then there is a commercial subscription that you have to pay for. So that's one option. That's if you still need that centimeter level positioning. If you don't need the centimeter level, if you're happy with half a meter or sub-meter, then there's many other options. So in Australia, we have now a system called SBAS, which stands for Satellite-Based Augmentation System. And that is a free correction service that comes from a satellite. It's actually, it's really was designed for aviation, to help pilots with approaches to landing. Which means it's also got this integrity component because it's a safety of life, but the service is free, so anyone can actually use it. So if you got just about any type of device, you can utilize that SBAS service, and that will get you to about half a meter.
Okay, so from what I hear, there's a distinction between the technology, so the antenna and the board, that a semiconductor manufacturer perhaps will provide you. And then there's the service that you can subscribe to that can also offer you high accuracy positioning. There's a difference between the two.
Yeah. So you got options on either side, right? With on the receivers, there's again this professional kind of high grade receivers that if you are a professional user, that's the type of receiver you'd want. But if you're not in that sort of category, then as I said, there's options at every different price point. Depending on how much hands-on you are, you can just buy a board and you can 3D print, as you know, Will, because you've done it
Yeah.
before. You can make your own little box, and it's going to work. And then you can take some sort of Android app, for example. Again, there's hundreds of those. Some are free, some are paid, but not very expensive. So there's all these different approaches that you can take, which is really good because you have many different options. So that's on the receiver side. And then on the services side, as I said, yeah, you can connect to RTK, either again in some countries like Australia, you can do it for free. You can do the commercial service. Again, there's different types of commercial services depending on your needs. And then you also got free satellite-based services. So I mentioned SBAS in Australia, the SBAS service called SouthPAN, Southern Position Augmentation Network. That in itself, it's actually got three different services. Two of those are sort of original kind of SBAS, if you like, which is that sub-meter instantaneous. But the last one is another interesting one. It's called PPP, or precise point positioning, which can get you down to about 10 centimeters, but not instantaneously. It needs that convergence period of 30, 40, 50 minutes. Just sort of depends. But again, there are use cases for that. If you need the 10 centimeter accuracy and you're prepared to wait for that long, that's another option. Another thing I mentioned in my presentation was Galileo High Accuracy Service, or Galileo HAS. That's actually a global service, which gives you about, they claim 20 centimeters worldwide, except at the moment, they're saying they can't guarantee that in our region, in Australasian sort of Southeast Asian region. And the reason is that because the way PPP service works, you need a ground network of reference stations. And then you use those stations to compute corrections to satellite orbits and clocks. And then you send those corrections from a communication satellite down to the users. And that's how a lot of commercial PPP services work. They have this kind of ground network all over the world. Typically, it's maybe 100 stations, maybe more, maybe less. With Galileo, it's different. They only have 14 stations, but the caveat they have, they can only put those stations on European territories, which means there's a lot of stations in Europe, and then there's another few sort of on European territory. So there's a couple in the Pacific, in New Caledonia and Wallis Island, and then the next one is in Reunion Island, which is off Africa. And there's nothing in between in this region. That's why they're saying they cannot guarantee the service in this region. But for me, it was interesting to test it when I was in Malaysia. So I did, and I tested it. I had very limited time because I was at the conference, but I sort of put the receiver up for half an hour and actually got down to 20 centimeters, which is what I said in that post, which is quite interesting. And again, it gives users in Malaysia and I guess in Australia another option.
Yeah, that's fantastic.
Mhm.
Was that just around Kuala Lumpur, or sorry, it was Kuching?
In Kuching, yeah.
Okay.
In Sarawak. Mhm.
Is that south of KL?
It's on a different island. So Malaysia,
Okay.
it's on Sarawak, which is next to kind of Brunei.
So, what assumptions could you make about the coverage for around Kuching? Would you say that it might offer that 20% accuracy could be achieved, 100 kilometers around Kuching, or for the whole region?
It's for the whole region. Yeah.
Wow.
It's actually, as I said, it's a global service. So
Okay.
And again, as I said, I only had half an hour. The location I was in probably wasn't the best. It had a few obstructions. So if I was in a better location and if I would spend some more time, I'd probably get it down even less.
Amazing. Okay. And so was that just with an antenna hooked up by Bluetooth to your smartphone, or what was the equipment?
No, I had a receiver with me, like a server grade receiver.
Okay.
Yeah. And I also tested SouthPAN. That was another thing. So SouthPAN against Australian New Zealand service, it only meant to operate if you kind of draw a box around Australia and New Zealand, that's the service coverage area. But the footprint of the satellite is much wider than that. So I thought, okay, well, why didn't I try that in Malaysia? And again, for SBS, as I said, it's typically about half a meter, 0.4 of a meter. That's probably the best you can get out of it. And funny enough, I got 0.4 of a meters in Malaysia. So again, that's another option
Wow.
for someone who only needs that type of accuracy, half a meter accuracy. That option is there as well.
So it almost makes me think those governments have kind of got a freebie.
Look, to an extent, obviously, there's no guarantees or no support. You know, if it doesn't work and you're in Malaysia, you
You
can't
can't
call
call the
Australian New Zealand
SouthPAN
government.
helpline.
Exactly.
Hey, I'm from
but
Malaysia.
it's
Okay, so just about the technical aspects for a bit. You said that. So, how many satellites are in the Galileo constellation?
look, all of those constellations are about 30. I'll have to check exactly,
Okay.
but it's plus or minus 30 satellites.
All right. So you got 30 odd satellites that are in what? Low Earth orbit?
Medium Earth orbit. So we're talking around 20,000 kilometers. Again,
There's,
plus minus. So there's 4 constellations: GPS, GLONASS, Galileo, Beta. I think they're all from 19,000 to about 23,000 kilometers. That's the orbits.
wow. Okay. So there is this constellation from a given regional or national global navigation satellite system sitting out there at some distance from the Earth of the order of tens of thousands of kilometers away. So that's one aspect of it. You said there's also a network of ground stations whose position is very precisely surveyed and is known. And that precise location can be compared with what the constellation is saying that same location is. Is that a key aspect
Exactly.
here? Yep.
Yes. And
And
what that allows you to do is compute the different types of errors
yep.
and corrections. Yeah.
And furthermore, you said that these augmentation systems like SouthPAN involve another satellite that receives the corrections from the ground stations and broadcasts that augmented and possibly more accurate position to those underneath.
Exactly. So those are geostationary communication satellites. So geostationary means it always sits above a certain point on Earth. And then, yeah, the way it works, so you've got that ground network, you take the data from all those stations, you compute all the corrections at the processing center, and then you send the corrections via an uplink station to that geostationary communication satellite, and from there it gets broadcast down to the users.
Okay, so
And
there's a
those
couple.
satellites
Yeah.
are geostationary orbit, which is about 36,000 kilometers.
Oh, so they're even further out than the
Yes,
positioning constellation.
correct. Yeah.
Fascinating. All right, so a couple of things have to be said here. First of all, humanity has achieved some pretty outstanding things. Like,
And
this is crazy.
it's only moving ahead and changing very fast. Now, the new cutting edge thing now is new positioning constellations in low Earth orbit. So they're now starting to emerge because GNSS has a few inherent challenges. Main one is its vulnerability. So the signals are quite weak and they're very easy to jam and spoof, and that's what's happening all over the world now, especially all the conflict situations. So it's a big concern, and that's why we're seeing a rise in this Leo constellations. And the interesting about them, they're not done by governments like GNSS; they're done by private companies. At least
These
some
low
of them.
Earth
There's a
orbit
couple of
constellations.
Yes. And for those ones, because they're at altitude of about 1,000 kilometers, so a lot lower, so they can cover much less area on the Earth. So you need a lot more satellites. So instead of 30, you need about 300, somewhere 250, 300, depending on your design. But the satellites are much smaller as well. So they're a lot easier to launch. If they fail, you can just launch another one. And inherently, because GPS is 50 years old this year, right? So these companies have 50 years of learnings when they design their systems. So they can do a lot of different smarts. They can have authenticated signals which you can't spoof. They're much stronger signals because they're closer to the Earth, so they're going to be harder to jam. What else? Obviously, there's more satellites that they're going to provide better positioning in areas where GNSS struggles, like in urban canyons, for example. So that's an exciting area to watch. We're going to see it unfold in the next few years.
Yeah, absolutely. It is exciting. I mean, yeah, I was sort of flagging before that just in a general sense, it's incredible what this species has been able to do. And also this to flag that this is in the positioning, navigation, and timing subindex of the Geospatial Index. And we'll get to this later on, but there's about 23, it seems, publicly traded companies that somehow make the satellites or offer general services to do with positioning, navigation, and timing. So just for anyone who's interested, yeah, this is sort of the theme that we're working on in our general geospatial industry here. You mentioned before SBAS, or satellite-based augmentation system. And I want to go through a few different terms that you've mentioned. That was one. Another one is jamming. Another one is spoofing. You also mentioned safety of life or authentication and why that's important for flying planes. So can we just dispense with a few sort of bits of terminology here? What does jamming mean? What does spoofing mean? And that will then help us understand the meaning for PNT customers and clients and governments of those that sort of use high accuracy positioning or resilient positioning, why the low Earth orbit solutions are important. Then we can shift over to why SBAS is important in the context of planes. So yeah, what's jamming? What's spoofing?
Okay, so jamming essentially is sending out an RF signal which is going to interfere with other signals, right? And GNSS signals, because they're coming from 20,000 kilometers, by the time they reach the Earth, they're very weak. And if you have another generator on Earth that's going to pump a very strong signal, it's just going to wipe out GNSS signals. So what jamming does, essentially, it's going to make you lose your positioning. So if you're any type of, in a car or drone, especially a drone, right? If you're flying a drone and suddenly you got no positioning, so you don't know what to do.
So
It's
this is
just going
common
to
in
crash.
warfare then?
Oh yeah, of course.
So there'll be like a pod that sits underneath the wing of a plane.
Oh, it depends. You can have it on a plane. If you're talking about a jamming system, you can have it just on Earth or anywhere, and it's just going to jam any RF that's in that area. And depending on the size of your jammer, so the smallest one you can actually buy on eBay for $30, and it's just that small, and it's probably going to wipe signals maybe in 100-meter zone. Highly illegal, for example,
I was
in
going to
many
say illegal. Yeah.
places in Australia as well, but you can buy it on eBay if you wanted to. Okay, so and then when you're talking war zone, it's actually the size of a truck, and that's obviously goes kilometers and kilometers away.
Incredible. Okay, so that's jamming, and then what's spoofing?
Spoofing is actually it's sending a fake signal, which means a receiver will get another signal. It will think it's a real signal from a real satellite, but because it's a wrong signal, it can actually position you somewhere else, which might be even more dangerous than jamming. So you could be positioned a kilometer or even a few kilometers away from where you are. So that's the
Okay,
big difference.
and that then makes it meaningful to have authenticated positioning signals because it will come with some sort of a message saying that it's from a trusted source.
Exactly. So Galileo have a service called OSNMEA, which I forgot what it stands for, but essentially it's an authentication technology. So if your receiver has that, it would be able to differentiate between true Galileo signals and something that's not. Again, there's many other different manufacturers at different other smarts in the antenna on the receiver on the algorithm level, looking at the sensitivity of the signal that you can potentially differentiate. But if your receiver doesn't have those smarts, then it could definitely be affected by spoofing.
Right. Okay. So that helps us understand why there's this investment, at least in this authenticated positioning service from Galileo, plus what can I say, low Earth orbit positioning constellations that have higher signal strength to help with the jamming. Yep. Okay. Right. Good. I think we're starting to understand a bit about the technicalities of these systems. So perhaps we can shift over to the meaning of SBAS. What are the issues for pilots that SBAS helps solve?
So FBAS was originally designed in the late 1990s in the US as an aviation technology to help pilots with the approaches to land. The biggest challenge for pilots is as they descend from above the cloud to below the cloud to make sure that they don't overrun or overshoot that runway and they don't miss it. And there are some really dangerous airports out there that got mountains. I don't know if you've seen, if you're on YouTube, just Google landing into Queenstown in New Zealand. That is scary. It's just basically you got clouds and then you got mountains with the peaks above the clouds. And as you descend, it almost looks like you're on a ship and you're trying to navigate something. And then you go into the cloud and you lose all visibility, but there's mountains all around you. And then as you descend below, you're in this narrow valley. Again, you see the runway, and again, there's just mountains. So SBAS helps a lot with that. It helps you, especially with the vertical guidance. And what it does, first of all, it actually gives you a correction, position correction. So your position is typically, less than a meter accurate. But the more important thing about SBAS, it's got integrity, which means if you think of like a cylinder, a bounding cylinder, vertical cylinder, and a horizontal cylinder, and for sure for 99.99999% that you're definitely somewhere within that cylinder. And that cylinder could be 30 meters in radius or 50 meters, doesn't matter, but you're definitely somewhere within that cylinder. And then if the cylinder is away from any obstructions, then you're safe. And then as you land, as you go into the clouds and as you descend, that you're definitely going to be in the right position, and then you'll be able to land safely. So it helps risk with the technical term they CFIT, control flight into terrain or a crash, essentially. So it helps you avoid that.
Right. So you said that was introduced in the 1990s or invented? When was it put into use?
It was put to use, I think, in the early 2000s.
Okay.
The
In the
first one
US
was in
first.
US, yep, and then it was in Europe, and then Japan and India followed suit. So I think they're the 4 certified SBAS systems at the moment in the world for certified for aviation. Then there's a few other ones that are going up. So Australia and New Zealand. Again, the service is there. It's not certified for aviation yet. Right, I think at the moment it's going to be about 2028. So it does take about 4 or 5 years to get all the pieces of the puzzle right. So all your reference stations, all the kind of modeling for ionosphere, things like that, and then you can actually certify it.
Okay. So I'm putting you on the spot a bit, but
Mhm.
do you have any statistics on the number of crashes or the frequency of crashes, controlled flight into terrain, that occurred before the introduction of SBAS and after? Has there been a measurable benefit to the aviation industry?
I don't have that statistics, but what I can tell you is when a few years ago we actually did an SBAS testbed for Geoscience Australia and Land Information New Zealand, and we did an economic benefits analysis, and we published together with Ernst Young. Ernst Young actually did the economic benefits
I remember
report.
reading that myself.
Yeah, it's still there, it's still available, but I'm just looking at that report, and what that report says is that um, on average, there's about 10 incidents in Australia, and in New Zealand. Obviously, not every incident becomes an accident. I think roughly 1 in 10 is. But if we look at the actual accident results over the last 30 years, in New Zealand, um, there's an average when an accident happened, an average of 3.7 fatalities and 2.3 injuries. In Australia, it's about 9.3 fatalities and also 2.3 injuries. So over the next 30 years, it's anticipated that there would be 146 fewer fatalities and 92 fewer injuries due to SBAS in Australia and New Zealand.
There we go. That's really nice to hear it in those sort of stark terms. So
Yeah.
how much does, at the risk of making a crass comparison between the cost of something and lives saved, but nevertheless, how much needs to be spent to stand up an SouthPAN?
Yeah, sure. So SouthPAN contracts $1.2 billion over
Yeah,
the 19 years, I think. I think that's the maximum you can have a contract for. So for over the 19 years, it's $1.2 billion. But
interesting.
the economic benefits, again, in that report, is 7.6 billion
Wow.
for Australia and New Zealand. It's not across the aviation sector, it's across all different industry sectors. The biggest one actually was in agriculture in terms of economics. And then the other big ones were road, construction, and mining. So in aviation, it wasn't the biggest in terms of dollars, but obviously very important. But what's interesting, economists can actually put a dollar value on anything, including human life. So I'm going to put you on the spot now. So how much do you think a human life costs?
Oh God, yeah. I mean, and that's why I said it's incredibly crass to even have this conversation at all. But
Yeah,
I guess where I was coming from is the government needs to make decisions about how the public money is spent. And it's interesting to consider the case that, because I don't know how many billions of dollars in tax revenue the government generates each year, but in the end, a case has to be made for each dollar that is spent from that. And yeah, it must be really interesting being a government decision maker, weighing up whether to spend that 1.6 billion over 19 years on SBAS as opposed to that same amount on some other intervention. So if I can hopefully not avoid the question by saying that.
no, look, of course. I mean, that it's up to the government to make decisions. But yeah, with SBS, I think so. That $7.6 billion figure of benefits, in my mind, it's quite a conservative figure. So the way that we came to that is we've actually done 27 projects in 10 different industry sectors, everything from agriculture, maritime, road, and we'll look at different use cases. But we could only look at a number of those use cases, and then we could really do the analysis. Right, how are you doing things now in this particular application? How would you do it if SBAS was there? That's the benefit. But there's been so many other applications that we just haven't had uh, capacity to explore,
Yeah.
and some of them we know, so they're kind of known unknowns. But there's a lot of them, what's called unknown unknowns. We just have no idea that what could be done. And people are smart, people are creative. If something new comes up, people will think of things to utilize it. So that number in the end is probably going to be bigger than that.
Yeah. So you mentioned 10 different, I guess, scenarios where you tested the economic case. Can you give us an example or two about, what you did in the field to test that out?
Sure. So yeah, there's many. So as I said, there's been 27 projects. Like in agriculture, we looked at, for example, tractor guidance. And again, those systems exist, the commercial. But again, if you have a free service which can give you 10 centimeters, it allows you what's called controlled traffic farming. So those more precise application, and it gives a barrier, it reduces the barrier of entrance for a lot of smaller players that can't afford to pay commercial subscription. They
From
have
John
expensive
Deere.
receivers.
Yeah.
Yeah, those type of things. Yes, for sure. So that was actually the biggest benefit economically. In maritime, again, we actually did a project where we put SBS receiver on many different ships that went all over Australia. One actually went down to Antarctica because we wanted to see at what point the signal is going to
Cool.
drop. So we did
Did it
2
make it all the
aviation
way to
projects.
Antarctica or?
It didn't go all the way, but it went much further than we expected it.
You guys really did everything. I'm jealous. I'm
Yeah,
in
that
the
was
wrong
that was
subindex of our geospatial industry. I need to move over to the PNT index. Okay, amazing. So we've covered off some of the terminology, the acronyms. We've got a bit of an impression of how a constellation works, how a network of base stations works, how they then interact with a geostationary communication satellite to broadcast their corrections. We have an impression of how much the Australian and New Zealand governments have chosen to spend on, for example, assisting pilots navigate the last stretch of a flight to landing through bad weather. And you've also importantly highlighted how there's even a benefit for farmers of this system. As we were going through all of that terminology, we touched on low Earth orbit constellations. I am interested to hear a bit about some of the entrepreneurs here, or if you have maybe a list of these new companies that are creating these new constellations.
Yeah, I'm actually writing a report on that, which will be available before the end of the year. But yeah, again, to give you that ecosystem, it also is quite broad and it kind of varies all the time. So you got a number of dedicated PNT constellations that people are working on. As I said, they'll have between 200 to 300 satellites. Then you got other people who are using what's called signals of opportunity. So actually looking at signals from Starlink and OneWeb and all these other satellites that are not PNT, they're communication satellites, internet, but they're still sending radio signals. And people are smart. They can actually analyze those signals. They can work out Doppler shifts of the signals, turn it into a range, and use it to compute positions. And there's papers been published that how people are doing that, and they're getting down to I don't know a few meters accuracy. So that's another
That's
kind of
amazing.
way.
So
Yeah.
even without this, it seems like there's a lot of smoke and daggers and clandestine. You all sound like a bunch of spies. So you said Doppler shift there. As you can tell, I'm shamelessly asking for a definition of every single term you use. So what is Doppler shift?
The Doppler shift essentially is you can work out as the signal comes through over time. You can work out a shift between two different epochs, and then you can turn that into a distance.
What's an epoch?
Well, epoch is a time. So what 1 second and then another second. So between two different seconds, you get two signals at 1 second at another second, and then you can difference that, get that shift and turn it into a range. So turning it into a meaningful distance to the satellite. And then if you got enough
Are
of
you
those
talking about a
distances,
frequency range?
yes, yeah. Mhm.
So from
So
one
shift in
second
the frequency.
So from 1 second to the next, a single GNSS satellite will send a positioning signal down, and you can see what the frequency is of that radio wave in the first second, and then from the same satellite you can measure the frequency in the second, and the difference between the two can be used to determine the distance from the satellite to you.
Pretty much. And that's right. And then that's how
I'm doing
GPS
really
works,
well
right?
here in my new career.
So all you're doing is imagining distances to satellites, right? And if you know where the satellite is, and if you got enough of those distances, more than four, for example, then you can compute
We can do
position.
trigonometry.
Yeah, pretty
Yep.
much. Yeah. But
So
with GNSS, that's easy, right? But with the Starlink and other satellites, it becomes very difficult because again, they're not positioning satellites. They are in low Earth orbit. So, there's hundreds of them. They're going all over the place. So, but again, people are doing it. So that's signals opportunity. And then the last kind of category is fused or integrated communications and PNT systems. So again, those Starlinks or OneWeb or Amazon is about to launch a constellation called Kuiper. And Europe also announced they're going to launch another constellation called Iris Squared. And there's a talk about actually fusing those communication systems and adding a PNT component to them. So there's different kind of ways that you can do it. And at the moment, no one really knows what's right, what's wrong, and what's actually going to prevail in the end. So it'd be interesting to see.
Yeah, it's just amazing. I mean, so Starlink, as I understand it, in the end will be thousands of satellites.
Yeah,
So
correct.
if a reliable signals of opportunity solution can be devised for Starlink and maybe all the other, because like Viasat also has its own satellite-based internet solution. Is it even worth spending the money for anything else if a reliable signals of opportunity approach to positioning can be devised?
Well, reliable is the key word. Like, how reliable are they? That's the key question. I'm not sure they will be able to replace dedicated systems, but again, it's all about the use case, right? If your use case, I don't know, let's say you're flying a plane, and for some reason all types of GPS, all types of positioning is out, can you just utilize those Starlink signals to get any position, like whether it's few meters, but you've got something, or on a ship? A ship, you don't need, in the middle of an ocean, you don't need centimeters. If you're good to 10 meters or 100 meters, as opposed to having nothing, that's the kind of idea here, right?
Okay.
But then if you do need that centimeter level, you're probably going to need the dedicated systems, whether it's GNSS or the new LEO ones that are coming on there.
Yeah. Okay. So you did mention a few of those LEO companies. Are any of them publicly traded, or basically, because the point of this podcast and the Geospatial Index is for the regular common folk to derive some economic benefit from our industry through the stock market?
Good question. I don't actually know. I know those companies. I know some of them are private companies, but I don't know whether they're going to be publicly traded. Yeah.
Okay. All right. So it's my job then to monitor the market news for if they ever IPO. Okay, so then sticking with the publicly traded company theme, I did assign you a little bit of homework before this episode, or I gave you the list of the 23 companies in the positioning, navigation, and timing subindex, because you are the first time we've had an expert in this industry on the podcast. So I hasten to say this is not financial advice. I am not asking you to be a stock analyst at all. I'm merely interested to use your expertise to hear from you if you have any opinions on any technological edge that any of these 23 companies may have over the others. Yeah, if you're comfortable to
Yeah,
comment.
so I'm just looking at that on my screen. Some of those companies I know, others I've never heard of, because there's probably big corporations that own the technological companies. But look, so some of the companies that I do happen to know, Honeywell is a very well-known company that do a lot of different kind of inertial types of sensors, and many other technologies
I
as
did
well.
see, by the way, just to say, I did see there's a pattern of inertial sensors and navigation. I almost was tempted to separate them out, but I thought that would be too much detail. But
Okay, yeah. Well, inertial, yeah, inertial basically gives you that relative kind of navigation, right? So it won't give you absolute coordinates, but if you got it fused with GNSS, you got the absolute and you got the inertial, and then if you lose your GPS, you can still use the dead reckoning to keep navigating. So a lot of times it's it's kind of together. What else? Iridium is obviously a very well-known company. They have a constellation of low Earth orbit satellites. There was another company called Satellus, which used the signals from Iridium satellites to provide alternative positioning and timing solutions. It's now been bought by Iridium, so it's now one company. But that's an interesting. So that's that low Earth.
so Iridium was like the first mover there for a LEO solution, but they're for communications, aren't they?
Exactly. The main thing is communications. And again, PNT was like this kind of subset done by a different company. Now they've sort of merged, and now they're providing PNT solutions as well, so comms and PNT. For positioning, it's not high accuracy positioning because they only have 66 satellites in low Earth orbit, so it's not enough.
Yep.
I think roughly they can get you down to about 10 meters, but for timing, it's more than enough. They can get down to again nanosecond level or a few nanoseconds. Because for timing, you only need to see one satellite at any one time, so you've got that sort of coverage. So if
So
you
is that good
need,
enough for a bank?
yes,
So banks
yeah, so
need
that could be
nanosecond, microsecond?
look, I don't know exactly. It it's not. It's definitely not any less than nanosecond.
Yep.
So it's yeah. I think most of them it's about microsecond level for energy grids and things like that. Some will come down to about nanosecond, but that's roughly the sort of edge we're talking.
I should say here, so it might be foreign to listeners to know that PNT or GNSS networks are used by financial institutions because, for example, on the stock market, it's important to know the timing of trades. And yeah, as I understand it, even stock markets will use these constellations to ensure integrity of the trading system. Is that right?
And even on your mobile phones, the time that is on your mobile phone actually comes from GPS, and most people don't know that because GPS have the most accurate clocks. So each GPS satellite has about 4 atomic clocks, and yeah, that makes it probably the most accurate timing system. That's why it's used everywhere in mobile phones, in financial sector, in critical infrastructures, which is very important as well. And the important thing there is time synchronization, time transfer. So if you got a clock, you at a certain point, then you got the time there. But if you need to transfer that time somewhere else, or you need to synchronize the time across your energy grid network or telecommunications network, you somehow need to transfer that time. And the easiest and the simplest way to do it is via GNSS
Right.
because it's available, it's free, it's accurate. So that's what people do.
Okay, so
But
just
if
thinking
for
through
some
that,
reason,
yeah,
yeah, mhm.
I just wanted to, because I have in my abroad and varied geospatial career, I did spend some time on a transmission power line project in South Australia. So time synchronization could be important there, where the control room sitting in Adelaide needs to have exactly the same time as all of the substations across the state of South Australia, which will respond to the command, for example, to shut off, 3 substations. So it's important that the clocks at those substations aren't 5 seconds behind the control center. Is that kind of what you mean?
Yeah. That's not 5 seconds, probably microseconds.
Yeah,
It all
sure.
has to be synchronized. Yeah,
Yeah.
but
Sorry, I
yes,
was just giving
definitely.
someone a heart attack mentioning such a massive difference in time.
But the problem is if something happens to your GPS, right? Whether it's a local jamming or something happening at the constellation
Okay.
level, then
So
all of
that
your
then
synchronization is gone.
So that shows also that jamming has more it impacts more than just the positioning of the tanks on a battlefield or the battleships, off in the Baltic Sea, which I understand is where a jamming incident happened, uh, showing a bunch of NATO ships on shore, for example. But you're saying that jamming could actually impact uh, municipal power supply, water supply, could have then a broad impact on society.
Def- Because
Wow.
once the signals are out, they're out. So you can't use them for positioning or for timing.
Right.
And that's why you need to have some sort of alternative or backups. For critical infrastructures, it could be, for example, holdover clock, right? So that if your signal's not there, then you can still hold the time for a certain period of time. Then it's going to start drift off, but hopefully you'll get your GPS
So that's
back.
kind of like dead reckoning, but for time,
Yeah,
in a
yeah,
way. It's a
in a way,
mechanical
yeah, that's right.
measurement
Yeah.
of, deviation from the known starting point in time.
Yeah. But then you can also look at the other alternatives for time transfer, right? And this is where we could use this Leo, either the existing one or the upcoming ones. Yeah. So this is the whole talk now in the PNT world is about resilience, and resilience means that you need to have backups in place. If something happens, if some sort of event happens, you need to have a plan B. If something happens to that, you need plan C, and so on. You need to have that
Yep.
multi-layered kind of strategy.
Sure. So speaking of which, you've gone through Iridium and Honeywell so far. What are some other components of that subindex that
Okay,
could be used as backup?
NextNav.
Next up,
NextNav
yeah.
is another company I know. It's an American company. They use terrestrial uh, systems, so not satellites. So they put their own kind of reference stations and they position themselves from those and time.
By the
Um,
way, they're doing really well in the market recently. And I
okay.
can't help but
Mhm.
wonder if it's because of conflicts around the world and it's almost trading as a defense stock.
Maybe. Yeah. Inmarsat, another geostationary satellite company. So they do communications. They also do a lot of SBAS and a lot of other commercial correction
Didn't
provision.
they provide the geostationary satellite for SouthPAN?
Yes,
Okay, yeah,
correct.
there
Mhm.
we go. See, I do know one or two
Spirent,
things about this.
yeah. So Spirent Communications is a very well-known simulator company. So they simulate GNSS signals, which you need to do for testing, and I work with them quite a lot. So yeah, you can simulate almost any type of scenario and see how it's going to react. And then another company, Viavi Solution, it actually they just bought Spirent
Yeah,
recently.
that's how I found
Mhm.
out about them. I'm not
Yeah.
sure. I've kept Spirent in there because I'm not sure if the transaction has been completed. And what I saw was there was actually another company that bid for Spirent, and then Viavi, I think, came along and bid higher or something like that. It was really interesting to see the fight.
Yeah.
Um,
Yeah. There's quite a few Chinese companies who are receiver manufacturers. So Unistrong, they make GNSS chipsets. Another one, Beijing BD Star Navigation, and Shanghai Navigation. So they big companies. They make GNSS receivers.
do you have any opinions on the quality of those? And is it because I remember when I made my SBAS receiver after getting the instructions from you and Chris, I think I bought the test kit or test board from a company in Taiwan. Um,
Mhm.
so I mean, is it common to get equipment that's reliable from these Chinese companies? Not to
Yeah,
suddenly
look,
suggest that they're
these
not reliable,
days,
but just interested to know your opinion
no,
on the
look,
quality.
yeah, these days there's so many GNSS manufacturers out there, professional ones for survey, let's say, and many other different fields. 15, 20 years ago, there was only two or three, like Trimble, Leica, maybe Topcon, and a couple of others. Now there's literally tens and tens. It's very hard to kind of make comments, oh, this one's better than the other one. They're all pretty good these days. They all come at different kind of price points, but generally speaking, unless you do a real kind of test and evaluation performance between different ones, you can't really say that, look, this one's better than the other.
Okay. Yeah.
That's one thing I'm thinking is with things like Suspirant, they make different types of simulators. They also make these things called record and playback systems, which means you can go out, you can record a scenario. It could be in an open field, it could be under a tree, next to a building, in a car, on a drawing. And then the good thing about it, you can actually play the same scenario into different types of receivers. And this is, if that's what you're interested in, you can actually take, if you want to buy one and you're not sure which one, you can actually take it and play the same scenario into different types of receivers and see how which one performs. And that will give you a very good independent kind of evaluation of it.
Right. Yeah. So every now and again, I go through a spurt of adding new companies to the Geospatial Index. And it was actually in the PNT subindex that I added a bunch of test equipment companies like Spirent. Yeah. So have you got any comments on any of the other companies in there?
In the list, Orbcom is another low Earth orbit provider. That's another one that I know. And that's probably all.
Yeah. Okay. Do any
The
of
other
them
ones I
stand
know.
out? Yeah. Do you have any, from your own knowledge of the industry and going to conferences and things like that? Are there any that are somehow more advanced technologically or working on something?
Um, Look, that would be hard for me to comment on, Will, because they are doing different things. Um, yeah, I'll probably
Okay.
lose out.
Yeah. No problem. Yeah. I won't put you on the spot anymore. But yeah, nevertheless, yeah, really nice to hear some commentary about or some effort to analyze my work here. Um, so yeah, I appreciate it.
But
Oh,
there are many other different companies. I'm not sure whether they're publicly or private. Yeah, maybe that's why they're not on your list.
no,
Okay.
no, please. I'd love to know any other that I've missed.
Oh, look, there's so many. Like if you look at that simulation space, Aspirant is a big one. Another big one is Safran.
They're in
Uh,
there because they bought so Safran used to be in the device subindex because I found that they had a tablet computer that was used for warfare and it was like a web map and all of that stuff. But that seemed to be they seemed to be getting less revenue than their PNT company because they bought a PNT company, quite a leading one. I forgot what it was.
Aurelia, yeah, I think
True. What was it?
Aurelia.
Aurelia. Yeah, yeah, that was the one. Yeah. So
Yeah. Mhm.
at the time that they purchased Aurelia, I put Safran in because I also have a equal weighted index fund. So there's
Mhm.
a hypothetical purchase of 100 Australian dollars of stock in each of the companies when they IPO or when they buy a geospatial company of some sort from another company. So, for example, Safran buying Aurelia.
But what about Trimble and Hexagon? Those companies.
Yeah, so this brings up the subjective nature of the sub-indexes. So of course they're in there. But Hexagon, I think I've got them in the network modeling sub-index because my subjective, I admit, assessment of where they have the most impact on our industry is for network modeling. But again, I'm perfectly happy to be corrected, and that's why I wanted to have this bit of a discussion with you because I view you as an expert. Like, and also for Trimble, I've put them in the surveying sub-index because my understanding is that they earn more money, they have more of an impact on the geospatial industry through the surveying equipment as opposed to the PNT specifically equipment that they might manufacture. But yeah, please correct me.
That's fair enough. Look, I mean, Trimble and they've probably been one of the original GNSS manufacturers, but obviously they're now expanding into
By
much more than
GNSS, do you mean antennas or the
receivers,
satellites? Receivers.
receivers, receivers. Yeah, yeah, yeah. But yeah, now they obviously do much more than that. And Hexagon's kind of the same. So Leica Geosystems and Novatel, they're the GNSS manufacturers, but Hexagon is the big umbrella that sits
So Hexagon
above it.
purchased Leica, did they?
Yes.
Okay.
Again, yeah, Leica is part of Hexagon's.
Yeah. So maybe this brings up another aspect of the maintenance of the index that I need to stay on top of. I need to go through the revenue breakdown or the segment breakdown for each company and look at where the majority of their revenue comes from and maybe do some rearrangement across the sub indices of these companies. Yeah. All right. Well, that's useful feedback too. Cool. All right. Well, yeah. Speaking of again, publicly traded companies that have that you have some expertise to do with. So Fugro has dropped a lot in the market recently. I understand you used to work there. So could you comment on their status in the industry? What makes them stand out amongst competitors? And also, importantly, what it was like to be an employee there.
Well, Fugro is a massive company. I worked as a hydrographic surveyor, so I worked on ships, on things like survey, or pipe lay or rig moves, that sort of thing. Anyway, where you need kind of positioning or navigation. So that's what I did. But Fugro is much more than that. They provide commercial positioning services. So the PPP that was mentioned before, they have their own service. I think it was mainly for maritime industry, but now it's probably expanded into other areas. They actually have a service for LEO satellites. So if you're a satellite provider in LEO and you need to know the positions of your satellites, they have a service for that. They also have, which I recently learned, they have a timing service as well called the Tomicron. So again, it's they're using the geostationary satellites from Inmarsat. But yeah, and you can have that again alternative timing source. So
Wow,
yeah,
so they do a huge amount in PNT then, because I only
yes,
sort of knew about them. Really, what sticks in my mind about Fugro is I think they were the ones that helped with the search for MH370.
yes,
So they
yep,
were, I've
that's right.
got them in the sea floor subindex because there's basically terrestrial surveying, which I've got as the surveying subindex. And then for hydrographic surveying or sea floor surveying, I've got as the sea floor subindex. And maybe I'm wrong here. So do you know if they get more revenue from hydrographic surveying or PNT?
I have no idea when it comes to
Yeah.
that sort of economy. I know that obviously they're very active in hydrographic
Yeah.
surveys, but they do have their own commercial services as well. And about the revenue, I really don't know.
Yeah, sorry, I'm putting you on the spot, but at least you've highlighted that they have compelling industry recognized offerings in PNT as much as hydrographic surveying. Okay. So would you say that they sort of dominate hydrographic surveying?
Look, I wouldn't want to comment because I've been away from that industry for quite a few years. When I just finished uni and started, at the time, this is now we're talking sort of early 2000s, there were really two big hydrographic surveying companies, Fugro and Thales. And at that time, I was actually
Thales,
applying to,
Thales.
yes, so the big French
The French,
prime,
they're
but
wow.
hydrographic surveying was a small part of the business. And I was actually applying for a Thales office, and then Fugro bought that hydrographic division from Thales. So I couldn't get a job for about a year. I had to wait till sort of the dust settled. So at that time, Fugro was the only big commercial hydrographic surveying company. But then as soon as that happened, all these small ones started to emerge, and over years they became big as well. So there's many different companies out there.
Okay, so but it still sounds like perhaps Fugro stands out in the market in terms of hydrographic surveying. Do you have
Look,
any? Yeah.
I think they're probably still the biggest one as far as I know, but again, there's many different companies.
Yeah. Okay. And what was it like to work there?
Well, at the time it was great. I was just out of uni. I was young. I didn't have a worry in the world, so I could spend 6 to 9 months a year offshore on ships and oil rigs.
Really?
Yeah.
Wild. Oh, you
uh,
have to tell, like, what were the waves like? Were there any massive storms or
Look,
what was
I
the
worked in
training?
training. Yeah, so training, you need to do like a 2-day course for undersea kind of survival. So if your helicopter crashes into the sea, how you get out of it and that sort of thing. But essentially, yeah, you just do that and a medical. If you need to physically pass the medical. Um, in terms of waves, look, I mostly worked in the Caspian Sea, which is like a landlocked sea. So it's not a huge kind of ocean, let's say. But the biggest ones we got to sort of about 8 meters of waves. So that's
Still pretty
pretty
big.
big. Yeah. And the funniest thing is always, you're out there, you have to do a job, you have to do a survey, and you have a client rep from the oil company, and then the weather forecast comes in and say, all right, in 8 hours there's going to be a storm, and then it takes 8 hours to get to a shelter, right? So the captain would always say, all right, we have to leave now, and the client rep would say, oh, but look, it's calm, keep working. So there's always
Yeah.
this kind of thing, and then so you keep working until last minute, and then you get into a storm.
Damn. A bit touch and go situations. So
No, look, we didn't really. No, I was never really in a big sort of safety one. But yeah, you do get into some waves occasionally. But
Amazing. So were you looking at a monitor, seeing the sonar return from a towed
Yeah, so
buoy?
in hydrographic, there's basically division between survey and construction. So if you're on a survey vessel, you might have 10 different types of sensors, an echo sounder, multi-beam echo sounder, a side scan sonar, some type of geophysical sensor. And as a surveyor, you need to keep track of the data that comes from all of those sensors. You need to keep the position of the ship, the kind of all the inertial, because it always kind of rolls and pitches. So you need to make sure everything is calibrated so the measurements you're getting are correct, because if it's not calibrated, what you think is a point on the seafloor, but it's actually somewhere else.
You've spoofed
So that's kind of
yourself.
your job. Yeah. And then so that's the survey. And then on the construction, this is where you kind of do pipe lay or rig move. So the rigs, they drill and then they have to be moved somewhere else. And it's a surveyor's job to basically get given a bunch of coordinates, and you have to make sure you move the rig exactly to those
Okay.
coordinates.
Okay.
And I've heard of some horror stories that, a surveyor forgot to put a minus sign on the latitude and actually went
Oh,
completely the wrong way and drilled a
$3 million
well,
and a month later, oh my God.
Yeah. It was literally, I've heard stories where, you drill and drill and there was supposed to be oil there and there's nothing there. And so what's
Oh,
going on? And you check,
God, you
and
can
it's more,
just imagine. There must be some amazing books to read about all these adventures, man.
There's actually an Australian guy that wrote a book about that. It had a really funny name. Oh yeah, it said, "Don't tell my mum I work on the rigs. She thinks I'm a piano player in a poorhouse."
Awesome. All
That was a
right,
great
she would
book, and it was
prefer
like had all these
that.
stories. Yeah.
Great. I'm going to have to buy that book. So, have you heard of the Ramform Titan triangle-shaped hydrographic survey ship from PGS, which has it's the triangle is so that at the back of it, it can have a lot more of these streamers hanging off the back.
Okay. No, I
Is
haven't
that
heard of it.
okay? Maybe it's. I've just wanted to see if it was recognized in any way, shape, or form in the
Okay.
industry.
I'm just looking at it now. So what it is, it looks like it's a seismic ship. So for
Yep.
seismic, the
So
way
that's
seismic
different to what
works.
you were doing, is it?
No, I work on seismic jobs. Seismic basically is where you got this sound gun that fires off sound waves, and then you got this long streamers, which could be, a few kilometers long. And then as the ship goes forward, and they have every 12 meters, they got like a hydrophone, so it picks up the sound wave as it goes back, and then you get this picture of all the different layers that are under the seabed, right? It just looks black and white, but geophysicists look at it and say, "Oh, okay, look, there might be oil there, there might be gas there," and then
So this
the
sounds similar in principle to the phase shift between epochs concept that we
just
were discussing
to
before.
an extent, yeah, because well, what happens? Because as you fire that wave, the ship goes forward, so it doesn't go straight down and straight up. It kind of goes on an angle and then goes back on an angle as well. And as that cable with hydrophones goes forward, it gets picked up at each hydrophone at different times, and that's why you get this kind of picture of the different layers.
Okay, and the point is that it's not the sea floor surface; it's
No,
below.
exactly. Yeah.
Yeah.
And again, I don't know, I'm really not an expert in that, and I know the technology has moved a lot, but when I was working, I think there was like, I think with gas, you could tell exactly whether there's gas there or not because it actually blocks out everything. So if you know there's a big white space and nothing there, you can tell that the gas is there. But with oil, you can't really do that. You can only guess. There was like 1 in 4, I think, a
Yeah.
chance of.
My understanding is it can be also be about the salt traps which under which oil can accumulate. So if you're looking for the salt traps, that can be a proxy. But this is just, when I spent 4 months working at Central Petroleum in 2012
Exactly.
to
You look for
2013 that I
this kind of, reservoirs or patterns, and if you find some, then there's a chance that yes, there could be
yeah.
some.
Okay, we could go on for hours. This is just
Yeah.
absolutely fascinating. But there was one question I had from actually someone on LinkedIn. So, just as a sign of how popular you are as an industry figure, Eldar, when I posted on LinkedIn that we were going to have this conversation, 19 people said or liked this post that I made. So obviously there's a lot of interest in what you have to say. And the post achieved 600 plus impressions. And there are also 5 comments. So there was a Dutchman, Joel van Kranenbroek. I will have catastrophically mispronounced that name. But he made some comments there, and I wanted to hear from you a response. So I'm just going to read what he had to say, and we can hear back from you. So he said, so what is the value of to trial Galileo HAS if the coverage is out? Did you receive the observations? He goes on to say, because 20 to 40 centimeters is pretty poor result, as we can get 5 centimeters after 10 minutes here in Europe. Also, the coordinates are in ITRS 2022 and therefore not immediately comparable with what you can get from my RTK Malaysian network, supposing it covers also the peninsular region. So yeah, thanks Joel for asking that question. And yeah, I'm putting you on the spot again, Eldar. Do you have any responses back to Joel?
Yeah, sure. So there's a few kind of separate things there. So first of all, why did I try it if the coverage is not there? Well, because I want to push the boundaries. I wanted to
Literally.
see, well, it's not supposed to work, but hey, let's try it, see if it works. And look, it did work. Did I get the corrections? Yes, I did get the corrections because that's the only way I could get down to 20 centimeters. I would never be able to get 20 centimeters without the corrections. 20 centimeters not as good in Europe. They can get better. That was to the point that I made at the start of the talk. Remember when I said that there's only 14 stations and 10 of those are in Europe? So, of course, the best performance you're going to get in Europe, it's going to be more accurate and faster. And in Asia, there's no reference stations. So it's not going to be as accurate and it's going to take longer. But the fact of the matter is the service is there, right? And again, for different types of users, that might be very useful. So for professional surveyors, which is I think where Joel is coming from, probably not so. They would probably use a coarse network like the Malaysian MRTK net, where you get centimeter level real time on the right geodetic datum. That's fine. But there's potentially a lot of other users in other industry sectors for which 20 centimeters might be very good. So
Yep.
that's what I was kind of getting at.
Great. So does my RTK cost? Do you have to pay a subscription fee?
Yes. Yeah, it's a
There we go.
commercial, just like most countries, it's a commercial RTK network. So there's like a yearly subscription. And again, for professional users, professional surveyors, that's totally fine. You got that survey grade
Yeah.
receiver and you pay that subscription and you get your service. But I'll give you an example. When we did the SBAS test, but we had people like from a railway company come to us and say they had 500 workers that have to walk the tracks every day and record faults. So there's no way you can buy each one of them a survey grade receiver, pay for a subscription, and they're not surveyors. You can't train them how to use that receiver. They don't understand
Exactly.
coordinate systems. They need something very simple that they can just sort of press a button, bang, record, but hopefully to a good degree of accuracy.
And if it's 50 centimeters, then you're down to an individual sleeper on the rail system, aren't you?
Exactly, and that what it a lot of times that what comes down to. With mining companies, they have boreholes every 2 meters, right? And they need to make sure they go to the correct one. So with SPAS, with Galileo has those type of services, they will get that.
Fantastic. Okay, so your point is that that region of the world now has for free, effectively, off the back of the investment of the EU, this positioning option available.
Exactly. And one other comment that I'll make is mobile phones is another very big and interesting area because the antennas in mobile phones are so bad that they just can't get very good positioning. But with things like Galileo has, and also in Australia, SouthPAN, those corrections are not just available from the satellite, they're also available via the internet, which makes it very interesting for mobile phone users. Because again, you can't get those corrections on a mobile phone from a satellite, but you can get it via the internet. So on Android phones, at least, you can get access to raw measurements on your phone.
Amazing.
So if you can get your raw measurements and now you got a free source of corrections, you can actually do some good things.
Yeah, that's fantastic. But obviously, for a real-time correction, you'll need to be in range of mobile internet.
Exactly.
Yeah.
Yes.
Okay. But nevertheless, yeah. There's a flood of innovation here. It's like just to ride the wave or keep up with all these developments. So yeah, as I say for all of the podcast episodes I do, I feel like I need a separate dedicated podcast to this topic. But yeah, I said a few times just like how incredible it is what we as a species have achieved, and I feel like the solutions, just in terms of these satellite constellations, to achieve nanosecond level timing, centimeter positioning, just what we've achieved is a real illustration of what we can do with science as a species. It's amazing. So I think there's a lot of inspiration to be had, for your field, Eldar, and yeah, I really appreciate you illustrating what we're able to do as humanity.
It was only going up like that, deeper. So it's just amazing. Even for someone like me who's in that field every day, there's just so many things happening. It's really hard to keep track of all the new technologies of what people are doing. So yes,
Yeah.
very much
Okay.
so.
So you said you're releasing a report on the Leo constellation's end of the year.
Yes.
Okay.
Yeah.
So
Just finalizing that.
maybe if I could put my hand up for another discussion early next year.
Sure. Happy to.
Yeah. Awesome. All right. So needless to say, if people want to reach out to you or keep up with your work, Eldar, how can they do that easily?
LinkedIn's probably the easiest way, or Frontier SI website. I think we got a generic kind of email, but if you send an email there, it will get to me.
Okay. So is that frontiersi.org.au?
Frontiersi.com.au.
Cool. All right. So yeah, once again, Eldar, amazing. And yeah, thanks so much for the inspiration.
No worries. Thanks for having me.